It's my immense pleasure to welcome you all for the immense tech series of 4.7 in the topic of mechanical engineering in day-to-day life. SA Engineering College, an outcome of Dharmanayudu Educational and Charitable Trust, was established in the year 1998. College has spacious, high infrastructure and peaceful surroundings with 4 lakh square feet of constructed area. The campus comprises aesthetically designed buildings that are networked by fiber optic cables and Wi-Fi. SAEC has emerged as one of the premier professional institutions in this region within a short span of time. The college maintains a high standard of education by providing a wide array of world-class academic facilities, employing highly qualified and experienced faculty members. The college offers 11 UG courses in engineering and 6 PG courses affiliated to Anna University and approved by ACTE. The institution is accredited by NBA and NAC with A grade. The Department of Mechanical Engineering was established in the year 1998 in our college. It was affiliated to Anna University in 2001 and got permanent affiliation in 2013. It has been accredited by the National Board of Accreditation (NBA) from the year 2009. The postgraduate program MEA CAD Camp was established in the year 2014 with an intake of 18 students. The department has been recognized as a research center by Anna University in the year 2012. The students are given hands-on training about the theoretical concepts they are learning through various labs such as Manufacturing Technology Lab, Fluid Mechanics Lab, IC Engine Lab, Heat Transfer Lab, CAD CAM Lab, Dynamic Lab, and Mechatronics Lab. The department has eminent faculties to guide the students in learning the various concepts of mechanical engineering. The faculties are well versed in the research and publish paper periodically in the reputed journals like WAS, SCI, Scopus. The Faculty of Mechanical Engineering also have patent grants for the research and innovation projects in the emerging field of mechanical engineering. In addition to this, various funded projects are also being carried out with the grants received from ACTE, DST, TNSEST, etc. The students are also encouraged to participate in various events such as design and fabrication of parallel hybrid electric race car solar vehicle championship conducted by ISIE every year. Ladies and gentlemen, it's my pleasure to introduce our distinguished speaker, Mohammad Said Nasim, today, someone whose journey from academia to entrepreneurship. Starting as assistant professional at SA Engineering College, our speaker dwelled deep into the realms of mechanical engineering, fostering a passion for innovation and problem solving. However, his journey did not stop within the confines of academia. Recognizing the pressing need for advancement in hospital equipment and furniture during COVID, he ventured into entrepreneurship, dedicating his expertise to improving healthcare infrastructure. Today, as the founder of Asia Mediatek, a thriving enterprise specializing in hospital equipment and furniture, our speaker embodies the transformative potential of mechanical engineering in addressing real world challenges within a keen eye for innovation and commitment to enhancing healthcare facilities. He is poised to enlighten us on the profound impact of mechanical engineering in our day to day lives. I will hand over the session to Mr. Nasim Said Mohammed.
Thank you very much for the wonderful introduction given to me. First of all, I would like to thank the management for inviting me to give this lecture. It's really happy that I'm back lecturing after a long time and to get engaged with students who are really enthusiastic. Without any delays, let's jump into today's today's topic. Before going into today's topic, our main heading today is mechanical engineering in day-to-day life. So, from the time you get up in the morning and do your day-to-day activities, you encounter a lot of mechanical engineering activities or challenges or tasks. So here I would like to go through two concepts which you could grasp through it easily and try to implement that in everyday life and appreciate how it works and how to design different concepts, right? So let's start. Okay, so the basic, what is mechanical engineering? So if you want to join into a course of mechanical engineering, you should know what it is, right? So it is nothing but a branch of engineering that focus on design. It's going to be design. If you are taking this mechanical engineering course, you will be designing and you will analyze. Once you have designed a product, let me say you are designing this pen, right? So I have two different pens here. Let's have an example. So you design this pen, so you give some dimensions to this pen, how big the pen should be, what should be the size of the tip, and how is the grip. So that is nothing but designing. Okay. Then you analyze it. Now I've designed this pen. I'm not going to make this pen directly. I'm going to analyze whether this pen will be good. How many times I could click it, whether it is strong, the spring inside this pen is good. So I'll be analyzing different parameters, right? So even though appearance, aesthetic also matters, right? Then after analyzing, then I go into manufacturing. So in that manufacturing part, what will happen is now I have a design. Now I analyzed that design and come into a conclusion that design is good. But if that design is not able to be manufactured, nowadays any design could be manufactured thanks to the latest technology and intervention of computers into the field of mechanical engineering. It's making our life very easy. We have a lot of technology like laser cutting, where you can cut sheets and plates very fast hit and assemble very fastly, right? So now this pen, I have designed it, I have analyzed it, it is okay, but if it is not being able to manufacture economically, that is one point in mechanical engineering to be noted. So we are always concerned about the working and the cost. Okay, if you're going to buy a car, the first thing you ask, what's going to be the mileage? Because you're very much bound that the car which you buy should not empty your pocket, right? And it looks good. And what is the initial cost of the car? So everything matters. So mechanical engineering deals with that also. So it should be able to manufacture easily. So once you design, you analyze your design, and that design should be able to be manufactured easily. And it does not stop with manufacturing. It also comes to maintenance, right? So once you buy a car, you need maintenance. After few kilometers of drive, your car will exert the waiting, right? So you need the maintenance. So in short, the mechanical engineering is nothing but designing, analyzing, manufacturing, and giving maintenance to a product. Okay. So this is what mechanical engineering is. I'm just touching briefly what mechanical engineering is, right? So I want to teach you a topic, how an item or product is going to be a balanced product. For example, I have this bottle. I don't know whether you'll be able to see it. So I have this bottle. If I place this bottle on the ground, the bottle should be stable, right? It should not topple down. So if it topples down, that means there is something wrong. You call this as a failure. The product has failed because the purpose of the bottle is to store water and it has to be up straight, right? So let's have a brief idea when an object is going to stand and when an object will topple, right? So you would be able to see in the screen, right? I have an object and I have got a red dot. This red dot is nothing but the center of gravity, CG. Okay. In short, let's call it as CG, the center of gravity. So all objects have a center of gravity. So what is the center of gravity? We need to know. Center of gravity is nothing but a point in an object where the whole mass lies on it. Okay. So if this is a perfect rectangle, okay, I'm not able to draw a perfect rectangle. Consider if this is a perfect rectangle, can anyone type in the chat where the center of gravity will be? Okay, the question is, I have a perfect rectangle. Uh, let's start with the two-dimensional. We'll progress to three-dimension later. So I have a perfect rectangle. So if I want to find the center of gravity, it is easy because this object is symmetric. So I can draw a line dividing this into two because it is symmetry, and draw a line like this dividing into two, symmetry, right? So this point, this intersection point of the two lines will be the center of gravity. Or if you have a rectangle, you can draw the diagonals. You can join the diagonals, and the intersection of the diagonals will be the center of gravity. So please mind my drawings are not accurate because I'm trying to draw with the mouse. So I hope that everyone adjusted. Okay, so let's deep dive into this image. I want you to have a close look at it. Let me erase something here. Okay, so what happens is the center of gravity or weight, you can call this as a weight also. Weight is nothing but a force due to gravity. So weight is nothing but a force. Weight is nothing but force due to gravity. Okay, so weight is nothing but a force due to gravity. So we can see the center of mass. So if this is the center of mass, the force is going to be downwards, right? There are two conditions for a body not to topple. Number one, you need to look at the base. Let me change the color. Okay. So we'll look at the base. See, this is the base of an object, right? This base is quite wide enough. Okay. Okay. Base, and the center of gravity is at some height from the base. So let me tell you a condition where you will have an object which does not topple. The condition is, for an object to be stable, it must have a wide base. So look at this base. This base is wide, and the center of gravity falls within the base. This line falls within the base. So this is going to be a stable. Okay. And one more thing, which is very crucial, is bring the center of gravity as close to the ground. Look, this this point is at some distance from the ground. If somehow I'm able to change my design and bring this point here, then it will be much more stable. Okay. So for an object not to topple, you have two conditions. What is the condition? One is the base must be as wide as possible. Number two, this you need to bring the center of gravity as low as possible. Okay. So what is happening here is I'm just going to push this push this tumbler with some force, right? So if I push this with little force, this condition happens. So what is going to happen? Now look at the base. The base has shortened. Okay, the center of gravity is here, and now also the center of gravity line is within the base. You can see it in the diagram, right? The center of gravity is within the base. So when you release the force, what is going to happen? The tumbler is going to come back to its original position. It is not going to fall down. Okay, this tumbler will not fall down. If I apply more force, I'm applying more force, right? So let me say, if I apply more force, the tumbler goes little bit more slanting, right? You can see this is the center of the tumbler, and now it's more slanting. It's more slanting. What happens now? Also, the center of gravity line is within the base. This is the base, right? So this is the base. This is within the base. At the end, at the tip, it is. At this condition also, the object will not topple or the tumbler will not fall. If you apply more force, now what is happening? Now what is happening? This is my base. Okay, this is my base, and my center of gravity line is out of base. When this happens, the object is going to topple. Okay, so basically, I just want you to grab an idea what will happen to our object, whether it will be stable or it is going to topple on applying some force. In order to be stable, there are two conditions. One, the base should be as wide as possible. Second condition, the lower the center of gravity, it is better. The second condition we have not seen. As of now, the first condition, we have checked out what the first condition is, right? The more wider the base, it is better, right? For example, let me draw a small drawing here. So if I have a tumbler like this, okay, I have a tumbler and this tumbler is full of water. Okay, it's going to be filled of water. So what is the base now? The base is, this is the base, and still it is symmetry. If you draw a line here, your center of gravity should be somewhere here, and the weight should be in the base. So you can push this tumbler little bit at some angle. At some angle, what will happen? This center line will cross the base, and the tumbler would come. Okay, that's an idea. Now, what is going to happen is if you draw a horizontal line here, dividing this into equal sides, the top portion volume is more than the bottom portion. That means the center of gravity will be at the top. If the bottom region volume is more, if I design like this, if I have a tumbler bigger base, the bottom volume is more. That means the center of gravity will come down. Okay, so let me erase and go back. You can understand more clearly. Okay, right. So, so we have seen what center of gravity is. So you can have an object in A position or B position as shown in the image, right? So can someone tell me in the chat which is better? We are applying a force. Both objects are applied with the same force. I'm applying a force here, applying a force here. So, in order to find the center of gravity point, it is symmetric. It is a rectangle, right? So, if it is a rectangle, it will be at the center exactly. So, you can draw two diagonals and find it will be somewhere here, right? If I draw diagonals. Same way, if I draw diagonals here, it will be here. From those two criteria, A and B, I would like to ask you a question. Which one has a low center of gravity? Okay, that means low center of gravity means it is from the ground, which has lower center of gravity. It is A or B. I would like to type in the chat. I would like people to participate and help me in making this presentation much more lively, right? So I encourage everyone to participate. So from this, you can see that the center of gravity of object A is much higher than B. And to be noting it, the A and B are almost the same object. You just tilt it, you will get B. Okay. So now, out of this condition 1 and 2, you can definitely say that whichever has a low center of gravity, that is better. So this, let me say, this has a height h, and this has a height y. You can compare that y is very smaller compared to h. That means from this criteria, lower the center of gravity. This is a good design. I'm telling it is a good design in the case that it is not going to tumble or fall. Okay. Whereas A has much greater chance of falling. Number two, wider base. So let's see. So I told you that from the center of gravity, the weight is always going to act downwards from the center of gravity. So let's say if this green is the weight, it is the weight force. Okay, so this has a weight force here. So this orientation also, you will be having a weight force which is aligned with the center of gravity. Okay, now I want you to compare with condition one. I told you wider base. Which has a wider base? Which has a wider base? A or B? A or B? Which has a wider base? This is the base of A. This is the base of B. So which has a wider base? Obviously, from the diagram, we can see that B has a wider base. That means, again, I tick mark for B. So, if the same object is oriented in a different way, and if it is subjective to a force F, B is more stable than A. See, it is a very small change. I have not changed the material of an object. I have not changed the object. I just changed the orientation of the object. Changing the orientation, you can see how strong, how stable that object becomes, right? So these are the two conditions which I want you to remember as we go down the presentation, right? The wider the base, the lower the center of gravity, it is going to be stable, right? So here I have a car. See, what is going to happen? The car center of gravity is somewhere here. Okay, same. Car center of gravity is somewhere here, and car center of gravity is somewhere here. Here, what is going to happen is we are riding this car in different slopes. We are making a turn in different slopes. So what is going to happen is this is let me indicate with a different color the base. Okay, so this is the base of the car. Here the base of the car. Here the base of the car. So I want you to say that whether this car will roll or not. In this condition, the car is not going to roll because the center of gravity, the weight force is within the base, right? I told you the wider the base, it is better. In this condition, the force is acting within the base. Okay. When I take this car is a smaller car, like you can say this low clearance car. The height of the car is low. Because the height of the car is low, the center of gravity will also be low, right? The center of gravity will also be low. So when you take this car to a light steeper road and try to take a turn, you will get this configuration. The center of gravity is down, the base is still wider, so it is going to be safe. Here also, when you take it to a much more tapered angle, so if the road is tapered much more to a larger angle, this is going to be safe as the weight force is within the base. Okay, now let's consider the same angle the car goes, but the car is different. Okay, now here you can see car like bigger SUV. It is a tall car. Okay, the height of this car is more when compared to one. Okay, let me label this as two. The car two, the car two is much taller than car one. So the center of gravity is here. In this condition, look at the base. The center of gravity is within the base, so it is going to be stable. Here, look at the base. The center of gravity is still within the base. Here, look at the base. The center of gravity goes outside the base. So this car will definitely topple in third condition. If I drive this car at a much steeper angle, this car is going to topple. So now let's look at the van. There is a difference between the center of gravity points, right? This is closer to the ground. This is much farther away from the ground. And now the center of gravity has gone really up because it is a truck. It has a really high, and if the truck is loaded, the whole dynamics changes, right? Because the weight is distributed on top of the truck, that means the center of gravity will be above, right? So bigger distance. This distance is really high. So what happens when you take this truck and you try to drive it in a smaller slope, which is this topples? Okay, so you would be able to say whether it is the truck will be toppled or the truck will be stable based on the two criteria, right? One, how wide the base is. Number two, how far my center of gravity is from the ground. Okay, so here you can see this car, right? So here, this is car A, this is a car B. It is just an example. So what is happening? This is the base. So here, look, this is the base. So the center of gravity is out of base. So this car topples. Here, the center of gravity is within the base. So this car does not topple. This is more stable. Okay, B is more stable. So if you look and appreciate these designs, you would also have seen this cone, right? In all roads, you can see this cone. And the cone is designed in a particular way so that it does not fall down so easily, right? These cones are kept in rows in order to divide the roads and try to alter the traffic, right? So you look into these design, it is designed in such a way that more mass is at the bottom. That means if you divide this cone into equal half in size, say this is 5 units, the top will be 5 units, right? But the center of gravity is going to be much below. Why? Because you can see, right, the volume of the cone above this center line and below the center line is different. The more volume, more density, the way it's going to be at the center is going to be at the down. Center of gravity will be down when come right. If it is symmetry, that means it will be in the exact line. And if I divide my cone into vertically, right side and left side are same. So center of gravity will be in the center line and will be at the bottom. And in order to make the cone very stable, what they are doing, they are making a bigger base. So that is what they have this square shape attached to the cone. Who could ask me, so why it is necessary to make the square shape, right? If you are making a product, less material you use and make a product, you are going to make more profits. Your production cost is going to be less. But the application won't suit, right? If I don't have this base, if I only have this cone, what will happen? If I only have this one, what will happen? Little bit of force is enough to topple this one. In order to overcome that, we have a square or a rectangular base, so that I could widen the base so that it could be much more stable, right? So let's go into more practical thing. So consider that you own a juice shop and you like to get a franchisee, juice shop franchisee, and you like to purchase some tumblers for your customers to serve fruit juices, right? So there are different options. That is what on the screen. So let me label this option as A, B, C. Okay. There are some criteria, right? So if you want to make more money, what you do is you try to give as little juice to the customer. So the customer should feel as if he is having a bigger glass, or he is enjoying the royalty or luxury of having something big. But the amount or the volume of juice in the glass should be less, because so that we could make more profit, right? If you are able to have a tumbler which can serve two servings, that means you are making profit of one glass, right? So what kind of a glass would you purchase? It is the same thing using, that is one criteria. So our objective is to have lesser volume of juice should be less. Number two, you will use this glass for a long period of time, right? So this glasses you go for washing and you will give it to the customer. The customer will drink and place it on the table, and it should not break. So in order it should not break, it should not fall down, right? It should not tip over. It should be stable. So we are going to look into some designs which now considering the volume as well as the stability. See, particular criteria to criteria, requirement to requirement, our design changes. Here, our requirement is our glass should have lesser volume so that it looks bigger. The customer feels he is enjoying that royalty. And number two, glass should not break. Or if the customer places on the table, it should not fall down or it should not topple. Okay, so now let's analyze the glass A. The glass A is pretty good. So let me divide this into two parts. The center of gravity, you can see from the geometry, the bottom is bigger. So the center of gravity will be at the bottom, somewhere here. And to this line, to y-axis, it is symmetrical. So the center of gravity it will be here. So one criteria is to lower the center of gravity. This is good. Okay. Now let's analyze this one. Now here, if I draw symmetry, and it is symmetry. Now more volume is at the top. That means the center of gravity. Let me choose a different color. Now let me represent the center of gravity. The center of gravity point will be at the top. Okay. Look again. Here the center of gravity is at bottom. Our condition is lower the center of gravity. Stability is good. So when you compare these two glasses, which is better? This glass is prone to less breakage due to tumbling or due to falling down. Okay, this is much stable because the center of gravity is gone up, center of gravity has gone down, and one more, look at the base. This has a wider base when compared to this one, which has a shorter base. So glass A is purely the leader here, and glass B. But we are comparing only the stability. When you compare the volume, class A will occupy more volume. That means you will be serving more juice to the customers if you use glass A. And it looks small. The customer feels, even though he's enjoying more juice, he will always feel that he has given something small and it is not that value of the money. Whereas when you give this glass to the customer feels that he has more juice, but actually less volume of juice is in class B, but the glass fails, right? So in A, the condition two, it is stable but more volume. In B, it is less stable but less volume. Both has an advantage. Let us go for glass C. So this is looks like a rectangular glass. So if I divide this equally, the center of gravity will be exactly here, and it has a wider base. Okay, when compared to A, C has a much higher center of gravity, but when compared to B, C has a much lower center of gravity. That means C is more stable compared to B. C is more stable compared to B. And when you compare its volume, this takes more volume than B, but less volume than A. Again, I'm saying C takes more volume than B. That means you will be pouring more juice in tumbler C when compared to B, but less juice in tumbler C when compared to A. So this is also okay. This is going to be stable, but still I'm not satisfied with the design because I want to satisfy both the conditions, volume and stability. Okay, sorry, I'm not able to write it fast. Stability. Okay, volume and stability. So what could be an ideal glass design? Okay, look at this. You can invert this design. Invert this design. So how will be the inverted image? Let's go. So this, I'm just inverting. I'm not good at drawing. Just I've inverted the glass. Now the opening is at the top, bottom is wide. So what is going to happen? Wider base. Okay. So look, when you divide this into two equal parts, bottom has more volume. That means center of gravity will be below the division of this line. So it has a wider base. It has a wider base. You brought the center of gravity down, and actually the volume is same as this class B. So you could design or buy a glass. You will able to D. If you are able to buy a glass D, you will be able to give customers lesser volume, but making them feel that they have been served more, and this is not going to break so easily. This is not going to topple down accidentally if the customer pulls the table or pushes the table. This is going to be more stable, right? So now I want you to think about this books. So this is a heavy book, smaller book, heavy book, like that have stacked one above the other. So if this system is stable, where should the center of gravity be? Okay, as an engineer, I'm not really interested in exact location where it is 25 meters, 25 centimeters from end A, 25 from end A. This is let me call that A end. Let me call this end as B end. Okay. So where is the center of gravity? I am not bothered. If the system is going to be stable, that means if this does not fall down, what should be the criteria? The center of gravity or the weight force should be between A and B. I don't know where it is. I don't know where it is. It could be here. Okay. But how I'm telling that it should be between A and B? Because the system is stable. Stable system, it has not toppled. So the center of gravity W, a weight, is going to be between the base. So what happens if I add more book here? More book here. Slowly this W will move. Let me choose a different color. This W will move here and adding a book. So again, I add another book. Let me add a purple book. Okay, I add a purple book. What happens? The center of gravity moves here. It will keep on moving because the mass is shifting towards the right. I guess you understand why the center of gravity is moving towards the right because the mass is shifting towards right and the mass is being added towards top. Actually, this point will be somewhere here. This purple point will be here. It will be moving up, up, up. Why? Because I'm adding book up, 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 and adding the book to the right. So the weight is distributed to the right and the mass is distributed above, right? So what happens? This is also stable. Now, if I again add another book, let me say hello book, again add another book, what is going to happen? The center of gravity will be somewhere here. So now the base of the book is here and the center of gravity is out. Now what will happen? The bridge which you have built will collapse. Okay, this is just to give an idea to say that if a system is stable, the center of gravity should be within the base. Okay, now let's look at this athlete, how he makes use of this principle of being stable to run. You can always see that athletes always start their race from the lower position and they climb up slowly. Why? Because when their body is at lower position, the center of gravity is much uh, closer to the ground. Okay, as this person stands up, his point will move up and up. So that's the reason why all athletes start from a lower place because they need acceleration. Initially, they need to accelerate fast in X direction, right? If they're accelerating in X direction, that means there is a force in X direction. So if they are standing and if they are trying to run, they won't be able to balance themselves or they won't be able to get that acceleration to move. That is the reason why all the athletes start from a much lower point. Right? You get this idea. Now you see this yoga lady standing and balancing. So what can you say where the center of gravity should be? She is in a balanced position. Okay, she is stable. She is moving her legs in order to make her whole system balanced. Okay, so this is her feet. This is her feet. So where should be the center of gravity? Point going through, right? Again, you can blindly say that the center of her weight should be within the small feet because if this weight force goes outside the base, she would definitely topple. She is able to do that by adjusting her body in such a way that a mass distributes and the center of mass lies somewhere within her feet. I think that you are able to appreciate the principle, right? She is balancing and the center of mass goes through a very small base here. Okay. Now let's see a sumo wrestler. This is a sumo wrestler, and you can see the center of gravity of the sumo wrestler. Sumo wrestler always use this position. Okay, they are always in this position. Why? Because number one, they widen the feet. Because more wider they are, it is very difficult to topple sumo wrestling. I guess everyone know what sumo wrestling is. You will try and apply force on the other person so that the other person topples down. The whole objective is to make other person fall down. So if you don't want to fall, this is what the sumo wrestlers use, the principle. They keep their leg and feet apart. Have you ever wondered why these people strangely or crazily keep their feet apart when others could keep their legs as close? Some people say, sir, they're very fat, so they must have a fatter thigh, so their legs are not able to be closer, so they keep the legs apart. No, they train and they make the body in such a way that they're heavy, massively heavy. They pound a lot of weight because more force, right? More force pull towards ground, and they keep their legs as wide as possible so that it is very difficult for the opponent to apply a force and topple. And they squat down. The purpose of squatting down is to bring the center of gravity as close to the ground. So this gives a clear advantage to sumo wrestlers who are shorter, who are heavier, who have bigger legs. So if you they have these genetics by nature, they would be ex- a, a brilliant sumo wrestler. Okay, so wider. That's the reason why the sumo wrestlers squat down. Their legs are spread as wide as possible, right? So now you can say this sumo wrestler taking on this wrestler, right? What he's trying to do is he has kicked his person leg. If his leg was here, if his leg was here, the center of gravity is somewhere here. The center of gravity is between the leg. So he will not fall. So the objective is to remove this leg. That is what this sumo wrestler is trying to do. He's trying to kick this person's leg so that his and now instead of this being his feet, now his base becomes this. If the leg is kicked up, okay, now the leg is up, now the leg is up, he has taken out his leg. So the gravity is somewhere here, the speed is somewhere here. That means this person will definitely fall this way. Okay, you can really appreciate how center of gravity principle is used in sports, especially in wrestling. Here also another sumo wrestler trying to take another sumo wrestler. Here, if you see this wrestler, wider base, he's stable. The center of gravity is squatting down. That means lower center of gravity. His center of gravity is somewhere here, right? So what about this person? The other person, the other person actually left it, okay. The other person legs feet are here, and his center of gravity will be up somewhere here. Why? Because he is in standing position. The center of gravity is more. So that means he's trying to push him, topple him. So at this position, it is easy for him to throw him over. So in order to throw him over, look at this wrestler using the principle of engineering. He squat down, feet wide apart, hold him tight, and he is trying to push him, angle him in this way, angle him in this way, lift him little bit up so that its center of gravity is going to be higher. So it will be easy to topple him. Okay. So we have learned this concept of stability now. As of now, we have learned how to make things more stable. Right now, we'll learn how to make certain things much more stronger. Okay. So because at the end of the session, you will combine these two ideas and you will be using in day-to-day life. That's what I want to say, share with you. Here you can see that I'm trying to balance my mobile with the help of a paper. I've placed a paper within these two books, book one and book two, and I've dropped my mobile. What would you expect? The paper would definitely crash through. But with little engineering, you can make this happen, right? So here what I have done is I have just folded the paper. You can see how it is folded. The paper just folded and again stretched. Okay. And now if you place the mobile, same mobile on the top of this paper is not going to collapse so easily. So what you have done, paper is same. What you have done, you have applied a very small principle by folding it. You can say this as corrugation. You see the rooftops, you'll have sheet like this. These are called as corrugated sheet. And if you see trucks, the side of the trucks, Tata Ace, all the trucks, right? The side of the truck wall is not a sheet. It is nothing but a corrugated sheet. It's like this instead of a flat sheet. Because when you do this, the material becomes stronger. I just want you to understand the concept. When you change the shape, the material gets stronger, right? Stronger. And you will use more material. Have this idea as you progress. Now, I want you to look into the different shapes which you see around every day. Okay, this is a stadium. The purpose of a stadium is you'll see lot of beams. There is no columns in the stadium. You can see beams. The purpose of beams is to support load. Okay, so the purpose of stadium should not have any columns. You should not have any vertical columns because it is a football field. People should play football, and the audience who are paying the money to watch the game come to the stadium in order to have uninterrupted view, right? So if you have so much of pillars, it is not going to satisfy our condition. So in order to satisfy, there is a long span of beam without any pillar, and this beam should carry the load. So how do they do it? It is a simple shape. I want you to appreciate and have a look at your surrounding. When you go out next time, when you go and see a telephone signal tower, you will always see this shape, triangle. There is something unique with triangle, and I love triangles because Triangle is the strongest shape ever. We'll all see how it is. Okay, just understand triangle is the strongest shape, and that is why these triangles are always used everywhere. See this bridge? These bridges are supported by these triangles, right? There is no need you need to have these triangles, right? If you have a bridge, you can have a bridge like this. You will have vertical pillars which holds the top and the bottom. When compared to this, triangular teeth are really stable, really stable. That's why you can see um, all elements made of triangle. Okay, these bridges. Look at these bridges. You can see these triangle shapes. Here you can see these triangle shapes made into different triangles. See the boat, sailing boat. You can see how the sail ropes are tied, and it makes a triangular shape. So triangle, it supports, stabilize, and stiffness. Remember the shape. Okay, why I'm asking you to remember the shape is triangle are the most easiest shapes, and it gives real rigidity to objects. That's why it is used in bridges, it is used in towers, and it is used elsewhere, right? Here is an example. I'm trying to balance a brick. I'm trying to balance a brick using this system. This is nothing but some jelly jelly gum, you say, or something. You have toothpicks, and this is nothing but squares, right? I have one square here, one square here, one square at the bottom. You can say this as a cuboid. All the side you have squares, and these squares, these lines, nothing but are toothpicks connected, right? And now if I place this brick on top, it will definitely collapse because squares are not strong. I told you the strongest structures are triangles. So if I make this structure like this, there is a triangle here, there is a triangle at the bottom, there is a triangle here. So if I have these one, two, three triangles and connected in this structure, this is called as a tetrahedron structure. There's nothing but collections of triangles. This is nothing but collections of squares. So on this is there is only one point here. I won't be able to balance a brick. So if I have more tetrahedrons, my structure is like this. These are nothing but tetrahedrons, right? Triangles. Three triangles joined. Okay, three triangles joined. If I then apply a load here, this will not collapse. Why? Because of a simple shape, triangles. I told you, right? Triangles are really strong. So now let's combine the two concepts together. What we have learned, right? One is how to make an object more stable. You should have a wider base, and the center of gravity should be as low as possible. Number one, and number two, what we have studied today is the best shape to bear load are triangles, right? So we'll go with an example, and with this example, practical example, we'll wind off. Not that I won't take you that much of time. If you see this, what is objective is to my objective is to make a chair, okay, with Pepsi tins, okay. So with this Pepsi tins, my objective is to make a chair. So what I'm doing is I'm connecting three cans here, taping some wood here, taping some wood there, making it a square, right? You guess, right? I'm making it a square. I'm building like this. I made the square. Okay, with this shape, you can't sit on it. What? So I should have another square. Another square. You get it, right? I'm making a chair. Now, if you apply a load, this will try to shake because there is no triangle here. So from this, you can improvise your design. So now what I'm doing is same design. I have a square and I have attached in another support here. So now you can see there is a familiarity. Here is a triangle. Here is a triangle. So this is going to be much more stronger. Now from this, if you add all four sides, so this is one side, this is the first side, back side, second side, third, fourth, you get a chair, same square, and have just placed what? One stick diagonally, making this as triangles. So it is stronger. If you want to make this much more stronger, what you will do is you will add another stick in this direction. So this makes one, two, three, four triangles. It becomes four triangles, right? So look how stable it is. Here, triangle, 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 triangle. Everywhere triangle. So this makes it ultimately strong. Okay. So now I want you to take this concept and go to your house and look. If you have a chair with four legs, how can you make the chair stronger? It's simple, right? I don't have a blank page. So, okay. So let me scroll this. If I have a chair which has four legs, right? Usually chair has four legs. So now you take this concept to your house and make the chair stronger. Initially, what you can do, you will try to form triangles. If I form a triangle here, it will be much more stronger. I want a three axis here. My legs has to go inside. Let me design a table. So instead of four legs, if you make one link, one more member join other two ends, it will be much stronger. If you want to make it much stronger, go to the back side, add two more X's there. This will create a much stronger table, right? With this, I guess that you would appreciate the structure, how to make a structure stronger by very simple changes, right? Triangles are very strong. You go outside today and look around everywhere. How many triangles you are able to find? You will be able to find more triangles. So this makes it really strong. And another concept which we have studied today is how to make things stable, right? With this, I would like to end my presentation today. Thank you for giving me a wonderful opportunity. I request the host to take over. Thank you.